As mentioned, I work for DNV in the Maritime Research Program, leading a group called Data-Driven Services. The presentations in this session will be very much in line with my topic of interest, namely digitalization and sharing of data between ship and shore. I think the next hours will be exciting, and I'm looking forward to learning more from the coming presenters. For the virtual audience, please use Pigeonhole to pose questions to the presenters. With that, I will kick off this session myself with a presentation and a paper called Containerized Immutable Data Sharing Utilizing Distributed Ledger Technologies. So this is in collaboration with my colleagues in Norway as well as in Singapore. Yes, so for today I will talk first about our novel onboard infrastructure for data sharing. I will then proceed to introduce a development we're doing on tamper-proofing of data to increase trust in data, and what implications this may have for various purposes, including what we think will become the machine-to-machine economy, and also some possible use cases of this data infrastructure as well as the tamper-proofing methodology. So first, a bit about this novel onboard infrastructure for data sharing. We use Telenor Maritime's Unified Hosting Service, UHS, setup as our experimental platform. So this is to move from basically what we see a lot of today, which is ad hoc computers being installed for various purposes on board vessels. So there may be several computers. We propose to rather replace this with a centralized cluster on board a vessel where applications are installed as software in the form of Docker containers. So this is a more standardized design and allows for easy management of applications. It also improves redundancy and is integrated with the communication systems on the vessel. So it also then allows more efficient resource utilization. And as illustrated here, we think that several actors may be interested in actually deploying software in the form of Docker containers on a vessel to utilize the data available on the vessel. For DNV, we are developing at the moment a tamper-proofing methodology, and a central part of this is hashing, or hash functions. So a hash function is a one-way deterministic function. There's no way of knowing what data produced a particular hash. There is no way to reverse engineer it. And the same input will always give the same output. So a small change in input will give a completely different output, a completely different hash. Imagine this a Docker container on the vessel, which is, for example, an IoT data collection microservice, collecting data in 10-minute batches. This occurs in what we call the data layer, and this can share these data to the trust layer, where a hash is generated and thereafter dumped from the hash layer, not from the trust layer, but not from the data layer. It remains in the data layer. After this, the hash can be published to the distributed ledger or the blockchain. And later on, when data is to be used for any purpose, an analysis of some kind, the first step may then be to verify that the data is indeed original by, again, hashing the data that the consumer has received and comparing this hash with that which is published on the DLT. If they are the same, you can know that the data is the original data and has not been tampered with. Similarly, you can do this for the data processing code to hash this, as well as the new data sets that are being created by an analysis step. In that way, it's possible to document the complete data lineage. So with these elements, a microservice environment, data storage and analysis on the vessel, and ship-to-shore communications, together with increased trust in data, this tamper-proofing methodology, we think one may build an ecosystem of applications where, for example, sensors or different machines may interact and share data, even sell data, and make payments to each other to make what we call the machine-to-machine economy. So further, with this, what possible use cases can one imagine? I think there are many. One which we are looking into is on CO2 emissions and the requirements, the MRV and DCS requirements to report CO2 emissions. As of today, this is just a reporting requirement, but we expect this to also turn into a taxation scheme in time. And with that, we believe the importance of truthful data from sensors will increase, and that there will be a requirement to actually know that these data has not been tampered with, as there will be an incentive to actually tamper with such data when money is involved. Similar, you could think of, for example, checklists on board vessels or condition monitoring data, health data about the machines on the vessel, also digital logbooks. And a case that I will talk a bit more about, a berthing of a container ship. So this little story, it's a little sci-fi story, is told from a data handling and DLT utilization perspective, and with limited knowledge on the actual steps of the berthing procedure. So please consider it as such. So imagine this vessel AI in a future autonomous vessel approaching, for example, Singapore to berth with an ETA in 14 hours. And then the MPA AI responds with requesting ID and dimension, draft, ship health state, and trade trust files. The vessel AI then collects this data from the onboard infrastructure and submits it to MPA. And based on this, the MPA may then create a smart contract and provide a berth slot, for example, 15 hours from now. When the berthing is completed, the cargo operations can start, and blockchain electronic bill of lading holder may be transacting, and cargo can be transferred to stack. So in the end, when this is done, the appropriate party can be notified and the smart contract completed, and the charges transferred automatically. And in the end, when this is verified, the ship may continue its voyage. I believe something like this will be needed for an autonomous vessel with no people on board. It will also be, I think, cost efficient. There was a study here from Singapore, from Nanyang and from the National University of Singapore, which estimated some global cost savings for container shipping if one assumed full adoption of blockchain. They estimated savings globally at 200 to 450 billion by 2040 and 3 to 7 billion in Singapore alone. Mainly, these gains were from reduced conflicting records, but also from bill of lading, printing and postage costs, actually. This makes it, I think, an interesting case. Some final words on our choice of blockchain platform. We are using in our experiments VeChain, which is different from in particular Ethereum, which it sort of derives from due to its proof of authority consensus algorithm, meaning that it is less centralized, but also it doesn't use this proof of work algorithm, which is very energy intensive and not very sustainable. So VeChain is much more sustainable in that regard. It also has lower and more stable transaction fees so that you know what each transaction will cost. So this is some key differences between these technologies. Also, just to mention, we believe this is also in compliance with trade trust design principles. VeChain Tor is public and permissionless. You can have, through this infrastructure that I mentioned, data both on-chain and off-chain, so that only hashes to confirm or verify data truthfulness is on-chain, while other data may be transferred off-chain. It is payload agnostic, so data can come in any format, also beyond the formats we are trying to use here, the ISO 19848 format. And it's open source. VeChain Tor is public, open source, and expandable. And it's, as far as we can see, ML-ETR compliant. So it satisfies these trade trust design principles. And with that, I thank you, and please also see our paper in the MTEC proceedings. And with that, I think I can open for questions from the floor.
So, thanks for the presentation. Very good and very interesting. With your hash data, so you encrypt using the hash function, can you then process it in encrypted form without having to de-encrypt it again? There are some tools that allow you to do that, and I'm not sure whether yours does.
Well, the hash function is not an encryption per se. It is a one-way function. So basically, you can have a gigabyte of data going down to a hash which is short. So there's no way to actually reverse engineer this.
It's just a logging key for the data that shows whether it's been...
It is a unique key which is deterministically determined by the data, but the data is no longer there.
Yeah, but there are tools that allow you to encrypt data, and then the end user can process it, but without having to de-encrypt it.
Yeah, okay, yes, that's, I'm aware of this, and yeah.
That's a good...
It's for machine learning without actually seeing the data, right?
It's used, and then the other area that's quite interesting is what they call franchise learning, where the algorithm or the model goes and looks at the data, but it doesn't keep the data. So a group of companies can agree that we'll all get a better model, but they're not sharing the data with each other.
I think this is very interesting, and I think this infrastructure is actually setting the scene for this, and it is actually an experiment we want to do with this in the coming months. So I think this is very interesting, yes.
I can put you in touch with somebody who does that, so...
Yeah, thank you. I'm just curious about the transaction fees on VeChain, because I mean, transaction fees on different platforms sometimes can be concerns to different stakeholders. So that's one question. Second is, how do you compare proof of authority with proof of stake in terms of why you choose proof of authority over proof of stake?
In terms of
the consensus mechanisms, I can understand why you don't want to use the proof of work because of the intensity of the computation. I just want to understand why your choice of the proof of authority versus a proof of stake as a consensus mechanism. Thank you.
Well, on this part, it is one of the main reasons is cost and the energy intensity. It is also probably less prone to malicious attacks because you have these 101 authority nodes, which basically means if you want to do a malicious attack, you have to convince 51 of the big companies who are the authority nodes to actually perform a malicious attack. While in proof of work, this is still very hard, but still it is more possible according to some literature. Your first question, I have to ask you. Yeah, the transaction cost, because transaction cost is related to the energy usage. This is much lower in this case with VeChain. It is also stabilized by a dual token system, meaning that they have mechanisms in place to adjust the value of the tokens, and so they can stabilize the transaction costs. No further questions? I see I have no one from online as well.